Let's continue with questions from section midpoint formula and equation of a line. Now, first let's discuss about parallel lines. In this question, it's given that there are two lines with the equation 7y equal to ax plus 4 and 2y equal to 3 minus x are parallel to each other. Then the value of a will be which of the following. So let's understand the concept behind parallel lines. Now any line, suppose here you can see in the figure L1, this line L1 is making some angle with the positive direction of x-axis, and let's say that the angle is theta, and that is also known as the inclination. If I look at tan theta, that gives us the value of slope for the line L1. And if I say that the line L1 and L2 are parallel, then they will have the same inclination with the x-axis, let's say theta, and therefore they will have the same slope. So the slopes of parallel lines are equal, which I can say m1 equals to m2, if m1 and m2 are the slopes of the lines L1 and L2. Now, also another thing is that if I rewrite the given equation in the format of y equals to mx plus c, then the coefficient of x will be the slope of the line and c will be the y-intercept of the line. So y equal to mx plus c is also known as the slope-intercept form of a line. But in the given question, the equations are not in the slope-intercept form. We can always simplify the equation and make it into the slope-intercept form. For example, if I take the first equation 7y equal to ax plus 4, I can just move the 7 to the other side. So I will have y equal to a by 7x plus 4 by 7. So now if I compare with the slope-intercept form, the coefficient of x is a by 7. So the slope of this line, if I say m1, will be equal to a by 7. And for the second equation, 2y equals to 3 minus x, I can move 2 to the other side. So I will have y equals to 3 by 2 minus x by 2. So the coefficient of the x term is minus 1 by 2. So I can say that the slope of this line is minus 1 by 2. And since the lines are parallel, the slopes are equal. So I will say that a by 7 is equal to minus 1 by 2. If I move 7 to the other side, a will be equal to minus 7 by 2. So option B is correct. Moving ahead to the next question. Here we have to find the equation of the perpendicular bisector for the line joining the line segment joining point A 4, 2 and point B minus 3, minus 5. So I've already drawn the rough figure to represent the question. We have a line segment AB, the coordinates of the points are given, and we have to find the equation of the perpendicular bisector of this line segment. The perpendicular bisector means it will be bisecting the line or dividing the line segment into two equal parts, and it's also perpendicular to the given line segment. Now we need to first find what is the midpoint of AB, because the perpendicular bisector is going to pass through the midpoint of AB. So let's assume it to be point P. So if I apply midpoint formula, I can easily find the coordinates of point P. So coordinates of point P applying midpoint formula is just the average of the x and y coordinates of the endpoints. So the endpoints are A and B. So x coordinates are 4 and minus 3. So I have 4 minus 3 by 2, and the y coordinates are 2 and minus 5. So 2 minus 5 by 2. 4 minus 3 is 1, so 1 by 2, and 2 minus 5 is minus 3. So coordinates of point P we have found out is 1 by 2, comma minus 3 by 2. So the coordinates of point P is 1 by 2, comma minus 3 by 2. Okay, now we know that point P lies on this line whose equation we are trying to find out. So the other thing that is required to find the equation is the slope of the line. So if I know one point on the line and also the slope of the line, we can always use the point slope form of a line to get the equation. Now we directly don't know what's the slope of the perpendicular bisector, but at least we can find the slope of the line joining AB because coordinates of both A and B are given. So let's find slope of AB. Let's call it M1. That's going to be difference of the y coordinates divided by difference of x coordinates. So let's look at the y coordinates first. For point A, y coordinates is 2 minus the y coordinate of point B, which is minus 5, divided by the x coordinate of point A, that is 4, minus the x coordinate of point B, that is minus 3. So this is 2 plus 5 divided by 4 plus 3. So that's going to be 7 divided by 7, and that is 1. So slope of AB is 1. And if suppose I say slope of the perpendicular bisector is M2, and I know that AB and the perpendicular bisector are of course perpendicular. So the product of the slopes of these two lines, product of slopes of any two perpendicular lines is always minus 1. So we know M1 into M2 will be minus 1. M1 is actually 1. The slope of AB is 1 multiplied by M2 is minus 1. That means M2 is minus 1. So the perpendicular bisector that we are trying to find, this equation, this perpendicular bisector, the slope is minus 1 and it passes through point P, which is of this coordinate. So I will say that therefore the equation of the perpendicular bisector according to point slope form is y minus y1 equals to m into x minus x1. x1, y1 are coordinates of one point on the line, and m is the slope of the line. We know both of these things. So the equation will be y minus y1. The y coordinate of point P is minus 3 by 2. That is equal to minus 1 multiplied by x minus of 1 by 2. The x coordinate of point P is 1 by 2. So if I simplify this further, y plus 3 by 2 is equal to minus x plus 1 by 2. Now it's a good practice to rearrange it and write it in the standard form of a linear equation with two variables. So move the terms on the left side. So minus x will be x plus y, and we have 3 by 2 minus 1 by 2 equals to 0. So that means x plus y, 3 by 2 minus 1 by 2 is 2 by 2, which will reduce to 1. So x plus y plus 1 equals to 0 is the equation of the perpendicular bisector. Moving ahead to the next question. This is sort of similar to the previous one, but here they are saying find the equation of the perpendicular dropped from point P onto the line joining AB. So this diagram represents the question. We have a line segment AB with the endpoints given, and from an external point P we are dropping a perpendicular. Let's say that PQ is perpendicular to AB. We want to find the equation of PQ. Now point P coordinates are already known. I just need to find out the slope of the line PQ. So what we did previously, we first find the slope of line AB. Let's call it M1. Again, difference of y coordinates divided by difference of x coordinates. So we have, let's say, 1 minus 2. No, we are looking at difference of y coordinates first, which is, let's say, 4 minus 3 divided by 1 minus 2. So it is 1 by minus 1, which is minus 1. So therefore, the slope of the perpendicular, let's call it M2, and the product of any two The product of slopes of any two perpendicular lines is minus 1. So m1, m2 product is minus 1. So we have minus 1 into m2 equals to minus 1. That gives me m2 equals to 1. So the slope of the perpendicular that I want is 1. And therefore again, if I apply point slope form of an equation, therefore equation of the perpendicular will be y minus y1 equal to m into x minus x1. So I have y minus y1 is the y coordinate of point P, which is 2. So y minus 2 is equal to the slope. The slope of the perpendicular is 1 multiplied by x minus of the x coordinate of point P, that is minus 1. Then if I simplify this further, y minus 2 is equal to x plus 1. Then if I move everything on one side, let's say the y minus 2 I'm moving to the other side. So I'll have x minus y plus 2 plus 1 equal to 0. That gives me x minus 1 plus 3 equals to 0. This is the required equation of the perpendicular. Then moving ahead to the next question, if the straight lines, these two lines, are perpendicular to one another, then find the value of A. So here the equations are given, but we need to first find the slopes of these two lines, and then we will apply the concept of slopes of perpendicular lines. The product is minus 1. So the first equation, 3x minus 5y equal to 7, I will try to rewrite in the slope-intercept form, which is y equal to mx plus c. So we have, let's say 5y will be equal to 3x minus 7, and y will be equal to 3 by 5x minus 7 by 5. So let's say the slope of this first equation is coefficient of x, which is 3 by 5. And the other equation, 4x plus ay plus 9 equal to 0. We just need to find the value of a. So let's move the other terms on the other side. So ay equals to minus 4x minus 9. So y equals to minus 4 by ax minus 9 by a. So the slope, if I call m2 of this line, is minus 4 by a, coefficient of x. And now these two lines are perpendicular to one another. So the product m1 into m2 is equal to minus 1. So I will have 3 by 5 multiplied by minus 4 by a is minus 1. So that means minus 4 3s are 12 by 5a equals to minus 1. That means 5a equals to minus 12 by minus 1. That is same as 12. That means a value is 12 by 5 or 2 by 5 as a mixed fraction, which is same as 2.4 as a decimal. Then the last question, ABCD is a square where B is 1, 3 and D is 3, 2. These are the endpoints of diagonal BD. We need to find the coordinates of the point of intersection of the diagonals AC and BD, and hence equation of diagonal AC. So for example, if I draw a rough square ABCD, we have we know the coordinates of B and D. B is 1, 3, D is 3, 2, and we have this diagonal BD. Now if I join AC diagonal, let's say the point of intersection is O, and they're first asking what is the coordinates of point of intersection of the diagonals. Now if we try to recall the properties of diagonals of a square, we should know that the diagonals are perpendicular bisectors of each other and the diagonals are equal length. So what is useful here to know is coordinates of B and D are known, and we know that the midpoint of BD is also going to be the midpoint of AC. So that's the point of intersection, midpoint of BD. So for part A, coordinates of point of intersection of the diagonals AC and BD is the same as the midpoint of diagonal BD. And if I apply midpoint formula, I will have the average of x coordinates 3 plus 1 by 2 and average of y coordinates 2 plus 3 by 2, which is 4 by 2, that is 2, and 5 by 2. So this is the coordinates of the point of intersection. And now if I want to find the equation of diagonal AC, I already know that this point lies on diagonal AC, point 2 comma 5 by 2, and I want to know the slope of diagonal AC. So like I said, the diagonals of a square are perpendicular also. That means I can use the concept of slopes of perpendicular lines. BD is already known, the coordinates of B and D are already known. So slope of BD, if I call it M1, will be difference of y coordinates by difference of x coordinates. So y coordinates are, let's say 3 and 2. So 3 minus 2 by 1 minus 3. So we have 1 by minus 2, which is same as minus 1 by 2. And if I assume that slope of AC is M2, then according to the condition, M1 into M2 will be minus 1. I will say that diagonals of a square are perpendicular. So therefore, M1 is minus 1 by 2 multiplied by M2 is minus 1. So I will have M2 value is 2. Alright, so I have slope of AC is 2 and it also passes through the point 2 comma 5 by 2. So I can use point slope form. So therefore, equation of AC will be y minus y1 equals to m into x minus x1. So we will have y minus y1 is 5 by 2 equals to 2 into x minus 2. So we will have y minus 5 by 2 y minus 5 by 2 equals to 2x minus 4. So we have 2x minus y minus 4 plus 5 by 2 equal to 0. So if I take a common denominator of 2, 4x minus 2y minus 4 minus 4 into 2 is minus 8 plus 5 equals to 0. So we have 4x minus 2y minus 3 equal to 0. This is the equation of diagonal AC.